us move on to the new lesson, motion in a plane. Already you people are aware the two terms, that is motion and rest. Remember, motion means change of position of object with respect to time. Rest means the body does not change its position with respect to time. All of you remember? And moreover, we define the motion and rest are what relative terms. Now we move on to the types of motion. So we can analyze the motion of an object as a one dimension. Motion can be analyzed under one dimension. It can be analyzed under two dimension. It can be analyzed in three dimension. What do you mean by one dimension? One dimension means motion. Generally speaking, we say if object describes a motion along a straight line, that could be called by name one dimension. Or else, if a position of object can be determined by using any one of three coordinate system, that can be called as what? One dimension. I repeat, if a position of an object can be determined by one among any one of the three coordinate system is called what? One dimensional. All of you remember there are three coordinate system, x, y, r and z. When you are locating the position of object, say under one dimension, either you can represent it as taking reference axis as x or y or z. Please remember, or I said either x or y or z. So another one is motion of an object on the surface can be called as a two-dimensional. Or to locate the position of object out of three coordinate system, any two coordinates can be used. Let me repeat, to locate the position of object out of a three coordinate system, any two coordinate system can be used. That can be called as what? Two-dimensional motion. Next, if the position of object is determined by three coordinate system, then it is called by what name? Three-dimensional. Or in simple words you can say motion of object in space. So when you are talking about motion of object in space, that is called three-dimensional motion. See, now motion in a plane. Just now we have given an idea. What is a motion in a plane, please? One more time. It is a motion of object on the surface or a plane, or the position of object can be determined by any two coordinate system. Okay, so that is what the motion in a plane. Can you quote some examples for motion in a plane? The best example is, have you seen a missile launching? The movement of a missile is a two-dimensional. The rotation of a gate wheel, that is circular motion, is two-dimensional. When a bullet is fired from a gun, is two-dimensional. When you hit for a six, how the ball describes its motion? Parabolic, which is nothing but two-dimensional motion. Okay, so motion in a plane. It is a chapter. Now we will go the definition. Motion in a plane. Okay, what is the motion in a plane? The motion of an object, or you can take it as a particle, motion of object on the surface or plane is called motion in a plane. What is other name? Two-dimensional motion. Okay, example please. Example, a projectile motion. Who will describe a projectile motion, please? A missile a projectile motion, a circular motion. These are two-dimensional motion examples. Circular motion or a ship moving on the surface of a water. Okay, these are what example for motion in two dimensions or simply motion in it. Now, see how the lesson motion in a plane unwinds. Just see, the motion in a plane unwinds under three headings. Please see. First one is here we are learning the concept of vectors. Okay, especially scalars and the vectors. I am talking about how the lesson unwinds. Okay, the lesson unwinds under these heading. One part is a scalar and a vector, but scalar part is very minimum. But we are discussing the vectors only. That's why I said the first part of this lesson is vectors. Second part is projectile motion. Okay. And third part is circular motion. This is how you can unwind the lesson. Agree? So the chapter includes these articles. That is scalar and vector concept. Second one is projectile motion. Third one is circular motion. Now, let us learn what are scalars and what are vectors. Already you people are aware. Scalars are the quantities having what? Only magnitude. How about vectors, please? The quantities having both the magnitude and direction. Scalars and vectors. Just see. And one more thing, how do you add scalars, please? Using ordinary laws of algebra. But how do you add vectors? Using special laws of what? Vector addition. See, these are the quantities having only magnitude. Okay, now let us talk about vectors. These are the quantities having both magnitude and direction. I think the first point is a very common one. Among the scalars and the vectors, we can easily distinguish them by using these concepts. That is, these are the quantities having magnitude and these are the quantities having both magnitude and direction. Next, scalars can be added by ordinary, means usual, ordinary algebraic laws. Okay, how about vectors? Vectors can be added by special laws of vector addition. Actually, you are learning the three laws of vector addition. They are triangle law of vector addition, parallelogram law of vector addition, and polygon law of vector addition. Special laws of vector addition. Okay. Do you know examples under scalars quantity or scalar space? Examples are very common. Time is a scalar, mass is a scalar, work done is a scalar, power is a scalar. Okay. Now how about the vector example? Even a velocity is a vector. Your force is a vector, displacement is a vector, okay, then torque is a vector. These are some examples under vectors. Just see them carefully. See how a vector can be represented graphically. See, represent a graphical representation of a vector. Now onwards, you may have two ways of solving a problem. One is solving a problem by graphical method. Second one is solving a problem by analytical method. So preferably in analytical method, we make use of what? Formulae. Whereas in a graphical method, that you are going to learn over here. Okay. How a vector can be represented graphically. So, graphical representation of a vector. A vector can be represented graphically by a vector can be represented. Okay, represented by a directed segment. This is important. See, how a vector is represented graphically means using the directed segment. So what you can see in a directed segment, please? This is a directed segment. Here, O represent a point of start, which we call as a tail. Point of terminal, that is this we call as a head. So here, the length of OA represent what? Magnitude of a vector. Just see one more time. How to represent a vector graphically using what? A directed segment. In this directed segment, the arrow head indicates the direction. And how about the length of a directed segment? That indicates what? The vector. Is it not the two aspects of vector are covered over here? Because what are the two aspects of vector? One is magnitude, other one is direction. Now we move on to the few more concepts that we may use in this part, that is vector concept. Now we have a position vector. So already we have discussed the motion of object on the surface is called motion in a plane. Now we have to make some plans so as to locate that object position with reference to our axis. In that direction we have a concept called a position vector. So what is the purpose of introducing position vector? See here please. A vector which gives a position of object. But how to locate the position of object, which is also with reference to the origin. Please remember, here a vector which is giving you the idea of the position of object from where? From the origin. And here also what is being used? The coordinate system. Once again, a vector which gives the position of object with reference to the origin of a coordinate system is called what? Position vector. Just see, our object is A. To locate the position of object on the surface, what I did that I used the two reference axes and this is the origin. When I join the origin to the point A, that OA becomes what? Position vector. Now you concentrate on the definition. What is position vector? A vector which gives the position of object. Here who is serving as an object is A with reference to the origin. Therefore, the length of OA gives you the magnitude of position vector. The angle made by the x-axis will give you what? The direction of position, the direction of a position vector. That you will learn on due course. Okay. Now we will move on to the one more vector called the displacement vector. See, what was your concept of displacement in one dimension, please? It is the shortest distance between what? Initial and final position of the object. Now when your object describes its motion in the plane, how to find its displacement vector? See, displacement vector, and here we are representing displacement vector in a plane. Please remember. Now you have a vector and a point of object position as P from your reference axis x, y. Okay, this is your object position from the origin. OP is the position vector initially. When your object P describes motion on the surface, means that motion of an object on the plane reaches say somewhere here at Q. Now how to locate its position from the reference origin, please? OQ. So therefore, is it not OP is the position vector of your object before the start of its motion? Now OQ is the position vector when it describes its motion on the surface. Now which is the displacement? What is the definition of displacement? Distance between initial and final. Just say initial and final. Agree? Here this becomes which one? P to Q is called displacement vector. Okay, so here what OP and OQ are position vectors. So this is how you can locate what displacement vector. Now, so we go on to the different types of vectors now, please. There are many types of vectors. We will learn them one by one. Okay, types of vectors. Sometimes we come across the vectors called the polar vectors. What are polar vectors? Polar vectors means the vectors having what point of start are called the polar vectors. And we come across axial vectors. Preferably axial vectors have a rotational effect. Means the vectors they act along the axis of rotation are called axial vectors. Now we have equal vectors. When the two vectors are said to be equal, so logically if they have the same magnitude and the same direction. Okay, we will learn one thing. Types of vectors. First one is polar vectors. These vectors have a point of what start. These the vectors have a point of start. Example, please. The displacement vector also has a point of start. Then force has a point of starts. These are called polar vectors. Next we have axial vectors. What are axial vectors, please? These have a rotational effect and act along the axis of rotation. Right? Can you quote example for this? Example means the torque is a very good example. Linear velocity can be expressed as a cross product, or as one more popular, angular momentum. Okay, these are the best example for what? Axial vectors. Next. Now we move on to the equal vectors. As the name itself indicates, when the vectors could be equal. See, the two vectors are said to be equal. Two vectors are said to be equal when the vectors are said to be equal when they have the same magnitude and direction, like this. Both the length and the length corresponds to what magnitude. You have to draw. Sorry. These are the equal vectors. Agree? Next, we have like vectors. Like I would say parallel vector. Means a line of action is parallel, like parallel vectors. When the vectors are said to be like, if the vectors are having the same direction are said to be like vectors. But another aspect is a line of action must be parallel. When the vectors are said to be unlike, when their directions are opposite, like parallel vectors, they have same direction. These are all simple terms. Same direction, that is like this. Magnitude may or may not be equal, but what is mandatory? Direction must be same. Next, unlike parallel vectors. These have opposite direction. Okay, the best example. The best example of unlike parallel vectors is when you apply force on to rotate the car steering. That could be an example of unlike parallel vectors. Okay, next. Next, collinear vectors. What are collinear vectors? The vectors acting along the same line are called collinear vectors. Sometimes you might have seen if many people are pulling the rope and all their force seems to act along the rope, that can serve as what? Collinear vectors. Means these are the vectors on the same line, like this. Here OM, AB and BC are collinear. Okay. So next, after collinear, we will learn one more vector called unit vector. This is important. Unit vector is a vector of magnitude unity. But please remember, unit vector concept was introduced specially to specify the direction. So we have I, J and K are the unit vectors. What unit vectors I, J and K represent? I is the unit vector specifying the direction along the x-axis. J is the unit vector specifying the direction along the y-axis. And K is the unit vector specifying the direction along what? The z-axis. So preferably, when we say unit vector, they actually specify what? The direction. But how to represent unit vector as a cap? Let's see. A vector of unit magnitude drawn in the direction of a given vector. is called the unit vector. Okay, how it is represented like this: a cap is equal to a vector by its modulus. Please remember unit vector. Let me reiterate, always unit vectors are used to specify what the direction, and usually what they have is a unit magnitude, but their purpose is to specify what the direction of vector. So how to write the unit vector? Please, a cap, we have to read this as a cap or a hat. This is unit vector. And here this is a given vector, and this is what the magnitude of a vector. Now we have a very simplified version to represent the direction in space by what term, please? I, j and k. I is a unit vector representing its direction along the x-axis, j along the y-axis, and k along what the z-axis. Okay, unit vector. Next concept is negative of a vector. So what does the negative of a vector mean? Actually, it is not negative. The meaning of negative is it is a vector of same type, but taken in vector of same type in the sense the magnitude part of vector is same, but it is taken in opposite direction. Then we call that vector as a negative of a given vector. Please remember, when we say negative of a given vector means it is not a different vector. It is a vector of same type, same magnitude, but taken in opposite direction. This is very important concept. Negative of a vector. Please remember, we are talking about the same vector, but the direction opposite. Negative of a vector. It is a vector of same type and same magnitude, but opposite in the direction. That is like this. If this is your vector, how do you write the negative of the given vector? Please take its vector as minus. So therefore, this is called the negative of vector A. So that is how you can see the different types of vector. And one more. Co-initial vectors. Okay, what are the co-initial vectors? As the name itself indicates, the vectors having a common initial point are called what? Co-initial vectors. These vectors have a common initial point, like this. Here I can say that OA is a vector, OB is also vector, and OC is also vector. But what is special about? Have a common initial point, are the co-initial vectors. Okay, and the last one, co-planar vectors. See, you people also represent a kind of vector. How your weight itself is a vector. So all the students are in the classroom. Then each student corresponds to a vector in the form of a weight. So students in the classroom constitute what? Coplanar vectors, because they are exerting the force on the surface or on the floor. So what are coplanar vectors? The vectors on the surface can be called as a coplanar. These are the vectors. These are the vectors on the plane. Okay. In this way you can learn different types of vector. Just go through the different types of vector, please.